Hello, sir. Shall I start? Okay. Let us start with the theory paper first. So in theory paper, first question was on diluting the solution of electrolyte, and options are both molar conductivity increases, molar conductivity and conductivity decreases, molar conductivity increases and conductivity decreases, and last one is molar conductivity decreases and conductivity increases. So your correct answer is molar conductivity increases and conductivity decreases, because molar conductivity is the electrical conductance due to the ion obtained from 1 mole of electrolyte. So that one is increases, and conductivity decreases when we dilute the solution of electrolyte. Then second question, uh, second question is this one, that consider the half cell reaction with the standard potentials. Ag plus electron give Ag. Standard potential is 0.8 volt. I2 plus 2 electron gives twice I minus. Standard potential is 0.53 volt. Pb2 plus 2 electron gives Pb. Standard potential is minus 0.13 volt. Fe2 plus 2 electron gives Fe. Standard potential is minus 0.44 volt. So here, question was you have to identify the strongest reducing and oxidizing agent. So among these, strongest oxidizing agent is Ag plus, because its standard potential value is maximum. So as per the basic condition, when standard potential value is maximum, it will act as a strong oxidizing agent, and when that standard potential value is minimum, means negative, it will act as a strong reducing agent. So your answer is Ag plus and Fe. Next question is the elementary reaction O3 plus oxygen gives twice O2, and you have to find out the molecularity and order of this reaction. As this particular reaction is elementary reaction, simply O3 and oxygen, 2 moles are involved. So it is a bimolecular. And if you write the rate law for this particular reaction, rate law would be like this. Rate is equal to K into concentration of O3 and concentration of O. So overall order of reaction will be second order reaction. Second order reaction. So here answer will be bimolecular and second order reaction. Next question, the unit of rate constant of first order reaction is usually expressed as. So there is a one general formula to find out unit of different order reaction. That particular formula is M, or here you can consider also mole raised to 1 minus N, L raised to N minus 1, and T inverse, where N stand for your order of reaction. So as order of reaction is given 1, so I can substitute n is equal to 1. Therefore, mole raised to 1 minus 1, L raised to 1 minus 1 per time. So answer will be per time. Okay, that is a unit of your first order reaction. Then there is one numerical in second question, that is the reaction A plus 2B gives 2C obeys rate equation. Rate is equal to K into concentration of A raised to half into concentration of B raised to 3 by 2. What is the overall order of reaction? See, to find out overall order of reaction, we have to just add up that powers. That is a 1 by 2 and 3 by 2. So when you add that particular 1 by 2 and 3 by 2, you will get that order of reaction, and it will be 4 by 2, that is your 2. So overall order of reaction will be 2. Very simple question. Then question number 6. Question number 6. That question is the molar conductivity of 0.05 molar BaCl2 solution at 25 degrees Celsius is 223 per ohm centimeter square per mole. What is its conductivity? What is its conductivity? Okay, so here answer is, or you can solve this problem by using the formula molar conductivity is equal to 1000 K upon C. So if you substitute the given values in that particular formula, you will get answer of that K, because your molar conductivity is given, that is 223 per ohm centimeter square per mole. Then concentration of solution is given, that is 0.05 mole per liter divided by 1000. So you will get answer 0.01115 per ohm centimeter square. Then next, calculate molar conductivities at zero concentration for CaCl2 and Na2SO4. Given that molar ionic conductivities of Ca2 plus, Cl minus and Na plus ions, SO4 2 minus ions are 104, 76.4, 50.1 and 159.6 per ohm centimeter square per mole respectively. So simply you can solve this question by using your Coriolis law. So according to Coriolis law, you can write that molar conductivities of CaCl2 is nothing but conductivity of that of Ca2 plus ion plus 2 into conductivity of Cl minus ion. Okay, then from addition of that conductivities of Ca2 plus ion and Cl minus ion, you will get answer for the molar conductivity of 256.8. And for Na2SO4, you can apply that ionization formula, 2 into conductivity of Na plus ion and conductivity of SO4 2 minus ion. So as values of ionic conductivity are directly given, you can substitute and simply add that values. So answer will be 259.8 per ohm centimeter square per mole. Then a reaction occur in the following step. Question number 8. First step is NO2 gaseous plus F2 gaseous gives NO2 F plus F, and that step is a slow step. And second reaction is F plus NO2 gives NO2F. That particular step is a fast step. So your question is write the equation of overall reaction and write down the rate law. Okay. So first of all, how to write that equation of overall reaction? Okay. To write that equation of overall reaction, simply you have to add that two particular given reaction. So as first given reaction is NO2 plus F2 gives you NO2F. It is plus F. It is my first given reaction, and second given reaction is F plus NO2 gives NO2F. So to find that overall reaction, I have to add these two reactions. So NO2 plus F2 plus F plus NO2 gives NO2F plus F plus NO2F. Okay. So things which are common that I can cancel, F will get cancelled, and final equation will be 2NO2 plus F2 gives you twice NO2F. So it is my overall equation. Okay. And second question is write down the rate law. See, rate law is always written from your slow step. So here this first step is a slow step. So I can write rate law from that first reaction. So rate is equal to K into concentration of NO2 into concentration of F2. Okay. Then next numerical which is given in the section C is for the reaction 2A plus B gives product. Find the rate law from the following data. Find the rate law from following data. So that tabular data is given. So in this type of question, to find out the rate law, first of all, we have to consider a general rate law that is like this here. We have to consider the general rate law like this. The reaction is 2A plus B gives product. So for this particular equation, I can write rate law. Rate is equal to K into concentration of A raised to X and concentration of a B raised to Y. Okay. So to find out rate law means we have to find out that values of X and Y from that given information. So from that given information, I can write three equations that R1 is equal to 0.15, which is equal to K into concentration of A. First information is 0.3 raised to X, 0.05 raised to Y. Second equation, I can write R2 is equal to 0.30 equal to K, 0.6 raised to X, 0.05 raised to Y, and R3 is equal to 1.20, which is equal to K into 0.6 raised to X, 0.2 raised to Y. Okay. So to find out that values of X and Y, first of all, find out the pair of equation in which either X quantity or Y quantity will get cancelled. So first of all, I can select equation 1 and equation 2. So divide equation 2 by 1. Divide equation 2 by 1. So it will be 0.30 upon 0.15 equal to K into 0.6 raised to X upon k into 0.3 raised to x. Here 0.05 raised to y, 0.05 raised to y. So 0.05 raised to y, 0.05 raised to y will get cancelled. So remaining equation is 0.30 upon 0.15 is equal to kk also get cancelled, 0.6 raised to x and 0.3 raised to x. So 0.30 upon 0.15, 2 is equal to 0.6 upon 0.3, 2 raised to x. So here value of x will be 1. Now to find out value of y, I can select equation 2 and equation 3. So divide So divide equation 3 by 2. So 1.20 upon 0.30 is equal to k into 0.6 raised to x upon k into 0.6 raised to x into 0.2 raised to y upon 0.05 raised to y. So that kk 0.6 raised to x, 0.6 raised to x will get cancelled. So 1.20 upon 0.30 equal to 0.2 upon 0.0. So here 4 is equal to 4 raised to y. So value of y will become 1. So value of x is 1, value of y is also 1. So ultimately our rate law become rate is equal to k into concentration of A raised to 1 and concentration of B raised to 1. So it is our rate law. Then question number 12 is there. In that question, your half question is of numerical, that is in a first order reaction, 60% of reactant decomposes in 45 minutes. Calculate half-life for the reaction. Calculate half-life for the reaction. As reaction is your first order reaction and you have to find out that particular half-life reaction. The simple formula of half-life for first order reaction is your T half is equal to 0.693 upon K. But in this problem, the value of K is not given directly. Instead of that, the 60% of reactant decomposes in 45 minutes. That information is given. So first of all, by using that particular information, we have to find out that value of K, and from using or by using that value of K, we can calculate that T half. So here, for first order reaction, equation of K is 2.303 upon T log to the base 10, initial concentration upon concentration at a time T. So as 60% is given, we can consider initial concentration as 100 and concentration at particular time T as 100 minus 60. So remaining is your 40. So by substituting that values, your K will be 0.0204 per minute. And by using that value of K, you can get T half by formula 0.693 upon K. And answer is your 34 minutes. Then in question number 13, one numerical is there. The standard potential of cell is given and standard potential is minus 0.76 volt. Calculate its potential. So you have to calculate the potential of that particular cell. So by using that given cell, you have to write down that electrode reaction like this. That electrode reaction is Zn2 plus 2 electron. It will give Zn. And your equation will be, formula will be E is equal to E0 minus 0.0592 V upon N log to the base 10, 1 upon concentration of Zn2 plus ion. So here standard potential is given, that is minus 0.76 N. Number of electrons required for the reduction are 2. Complete reduction of Zn2 plus ions are 2. Again, concentration of that Zn2 plus ion 0.02 mole. So by substituting that particular values in that formula, you will get answer of potential, that is minus 81 volt. Minus 81 volt. So that was about your theory paper. Now, multiple choice question paper. If you look at the first question is on passing 3 Faraday charge, the number of moles of magnesium deposited at cathode are. On passing 3 Faraday charge, the number of moles of magnesium deposited at cathode are. So, first of all, you have to write the reaction, that is, for any ion, for any given ion, you have to write that particular reaction, that Mg2 plus ion for complete reduction require 2 electron. So they will get completely reduced. So 1 mole of Mg2 plus ion require 2 moles of electrons. So on passing 2 Faraday charge, 1 mole of magnesium gets deposited. Therefore, on passing 3 Faraday charge, number of moles of magnesium deposited are 3 by 2, which is equal to 1.5. So your answer is 1.5. Then, second question is galvanic cell composed of iron and half cell with potential of minus 0.44 volt and 0.76 volt respectively. The E0 of cell will be. Now, as we know, greater the value of potential, it will act as a strong oxidizing agent. Okay, so from that we can decide E0 of cathode and E0 of anode. That positive value will be E0 of cathode and that negative value will be E0 of anode. So to find out that total E0 of a cell, formula is E0 of a cell is equal to E0 of a cathode minus E0 of a anode. And by substituting that values, you will get simply answer 1.2 volt. So answer will be 1.2 volt. Then, how many Faradays are required to liberate 8 gram of hydrogen? How many Faradays are required to liberate 8 gram of hydrogen? So again, I have to write the equation for the liberation of hydrogen. So to liberate that H2, 2H plus ion accept 2 electron to liberate 1 mole of hydrogen. So 2 Faradays are required to liberate 2 gram of hydrogen. 1 mole of hydrogen corresponds to 2 gram of hydrogen. So according to question, 8 Faradays are required to liberate 8 gram of hydrogen. So your answer will be 8 gram. Fourth question. 96500 coulombs corresponds to the charge on how many electron? So here, one Faraday corresponds to 96500 coulomb. So 1 Faraday corresponds to 1 mole of an electron. So it is a charge on 1 mole of electron. That is 96500 coulomb is a charge on 1 mole of electron. But 1 mole is nothing but 6.022 into 10 raised to 23. That is Avogadro number, that much molecule. So our answer will be 6.022 into 10 raised to 23. Which of the following metals could not be obtained on electrolysis of aqueous solution of its salt? See, in option, silver, magnesium, copper, and chromium. These 4 metals are given. Among these 4 metals, reduction potential of magnesium is less than that of water. Hence, their ions in aqueous solution cannot be reduced. Instead, water will be reduced. And secondly, that magnesium is highly reactive and has a strong tendency to form compound with water. It is not stable in aqueous solution and decomposes to form magnesium oxide and hydrogen gas before it deposited on cathode. So among 4 these given metals, magnesium could not be obtained on electrolysis of its aqueous solution. Then, the highest electrical conductivity of the following aqueous solution is of. See, electrical conductivity is depend upon number of ions. Now here in option, concentration of all 4 acids are given. Concentration of all 4 acids are same, that is 0.1 molar. First acid is acetic acid, then chloroacetic acid means one of alpha hydrogen of acetic acid is replaced by chlorine. Then fluoroacetic acid, one alpha hydrogen of acetic acid is replaced by fluorine, and last one difluoroacetic acid, 2 of alpha hydrogen atom of acetic acid are replaced by fluorine. So if you look at the basic key point of acidity, when number of electron withdrawing group increases, that acidity increases. So in difluoroacetic acid, 2 fluorine group, which are strong electron withdrawing group, they are attached at alpha position. So they will exert strong electron withdrawing group, and that particular difluoroacetic acid is the strongest acid. So in that case, ionization will be more. So higher the number of ion, higher is the electrical conductivity. So here answer is a 0.1 molar difluoroacetic acid. Then mark the false statement. First, a salt bridge is used to eliminate liquid junction potential. Yes, it is a true. That salt bridge is basically used to eliminate that potential, liquid junction potential. Second sentence is, the Gibbs free energy change delta G is related with electromotive force as a delta G is equal to minus NFE. Yes, this equation is also correct one. Then Nernst equation for the single electrode potential is, Nernst equation, correct Nernst equation is given there. And last one is, the efficiency of hydrogen oxygen fuel cell is 23%. So that last statement is a false one, because the efficiency of hydrogen oxygen fuel is about 70%. So answer is option D. Then next question. Element which can displace 3 other halogens from their compound is. So chlorine, fluorine, bromine, and iodine are given. As we know, the first halogen can displace lower halogen, or upper halogens can displace lower halogen. Means as a fluorine is a first member, that fluorine can displace lower all halogens. But if we look at a chlorine, chlorine can displace only bromine and iodine. Chlorine cannot displace fluorine. So the halogen which can displace three other halogen from their compound is fluorine, because it is a highly electronegative and can displace all lower halogens. Next question. Calculate the standard free energy change for the reaction. Standard free energy change for the reaction. Reaction is given, which is taking place at 25 degrees Celsius in a cell whose standard EMF is 1.02 volt. See, standard EMF is 1.02 volt is given, and you have to find out the standard free energy change. That is your delta G. So simply by using that formula of delta G is equal to minus NFE, you will get that answer. So minus 1 into Faraday value, that is 96500, into given your EMF value, that is 1.02 volt. Answer will be minus 98430 joule. So answer is option A. Then during the electrolysis of an electrolyte, the number of ion produced is directly proportional to the. During the electrolysis of an electrolyte, the number of ions produced is directly proportional to, that is, quantity of electricity passed. It is simply nothing but Faraday's first law, which states that the mass of substance deposited or liberated at any electrode is directly proportional to amount of charge passed. Therefore, answer is option C, quantity of electricity passed. Question number 11. That for chemical reaction, A gives product, the rate of reaction doubles when the concentration of A is increased by factor of 4. The order of reaction is. Here you have to find out order of reaction, means simply you have to find out the value of power in your rate law. So from given information, I can simply write first equation, rate is equal to K into concentration of A raised to X, as second statement is the rate of reaction double when concentration of A is increased by factor 4. I can write second rate law as 2R is equal to K into concentration of 4A raised to X. So if I take ratio of these two rate laws, it will be 2R upon R, which is equal to K into 4A raised to X upon K into A raised to X. Here it will be 2 is equal to 4 raised to X. So value of X is equal to 0.5. So order of reaction is 0.5, and answer is option C. 12th question. Collision theory is applicable to. See, basically collision theory is applicable to biomolecular reaction. So simple question, answer is your biomolecular reaction. Next, the slope of straight line obtained by plotting rate versus concentration of reactant for first order reaction is. So reaction is a first order reaction. So for that first order reaction, I can write the rate law as rate is equal to minus d concentration of A upon dt, which is equal to K into concentration of A raised to X, but value of X will be 1 because it is a first order reaction. So to fit this particular equation into straight line equation, that is y is equal to mx plus c, plus 0 is taken here. So here I can relate that equation with the straight line equation like this, minus dA upon dt can be considered as a Y. Then K, M, concentration of A, X, and 0 as a C. So when we plot the graph of concentration versus rate, concentration versus rate, the nature of graph will be a straight line passing through origin, and slope of this particular graph will be K. Slope of this particular graph will be K. So answer is your option D. Next question. For a gaseous reaction, the unit of rate of reaction is. So for gas phase, when reactions are gas phase reaction, instead of concentration, we have to consider the pressure. So your unit of rate law is nothing but atmosphere per second. Atmosphere per second. That is your option C. Next question. The increase in rate of reaction with increase in temperature is mainly due to. So as we know, when we increase the temperature, rate of reaction increases. This particular increase in rate of reaction due to increase in temperature is mainly due to increase in number of effective collision. If your collision is effective collision, that particular collision will lead to product. All collisions do not give you a product. So answer is option C, that increase in number of effective collision. Then the half-life of first order reaction having the rate constant K is equal to 1.7 into 10 raised to minus 5 per second is. Order of reaction is first order and K is given, and you have to determine the half-life of that particular reaction. So simply you can use the formula for first order reaction. T half is equal to 0.693 upon K. So if you substitute the value of K in that particular equation, you will get answer in second, because value of K is given in per second, but your options are given in per hour. So once you get your answer in second, you can convert that second into hour by dividing 3600. Here your answer is 11.32 hour. 11.32 hour. Option C. Then question 17. The rate constant of reaction depends on. Rate constant of reaction. Rate constant is nothing but your K. So K is ultimately depend on temperature. This relation is given by your Arrhenius equation, that is K is equal to A into E raised to minus EA upon RT, which ultimately says that your rate constant depend upon temperature, not on mass, weight, or time. So answer is option A. Question number 18. The rate law for the reaction sucrose plus water on acid hydrolysis gives glucose plus fructose is given by. See, if you observe this particular reaction, you will know that this particular reaction is an example of pseudo-unimolecular reaction. So when we write rate law for pseudo-unimolecular reaction, rate law becomes rate is equal to K into concentration of sucrose into concentration of water raised to 0, because the pseudo-unimolecular reaction are the reaction which expected to behave higher order kinetic but actually follows first order kinetic, because quantity of water is excess, so that concentration of water do not affect the rate of reaction. So your answer is option B. Rate is equal to K into concentration of sucrose raised to 1, concentration of water raised to 0. Rate is independent of concentration of water. Then question number 19. A graph plotted between log of K versus 1 by T for calculating activation energy is shown by. 4 options are given. You have to find out correct graphical representation from that 4 option. So to find out that nature of a graph, here let us start with that Arrhenius equation. Your Arrhenius equation is K is equal to A into e raised to minus EA upon RT. So by taking log of both sides, equation become ln K is equal to minus EA upon RT plus ln of A. So by converting into log to the base 10, you will get the equation log to the base 10 of K is equal to minus EA upon 2.303 R into 1 by T plus log to the base 10 of A. So now I can relate this equation with straight line equation, that is y is equal to m x plus c. So when I plot the graph of log k versus 1 by t, okay, the nature of graph will be like this. As this equation obeys a straight line equation, no doubt nature of graph will be a straight line, but here slope is a negative slope and value of c means intercept value is there. So nature of graph is like this: negative slope and intercepting at that particular axis. So your answer is option B. Then from the following, which is a second order reaction? 4 options are given. So to find out the order of reaction without any other information, simply you have to observe the unit of that options. As you have to find out second order reaction, you have to find out the option where unit of second order reaction is present. So to find out the unit of second order reaction, we have that one general formula, that mole raised to 1 minus n, liter raised to n minus 1, and per time. So as we want second order reaction, we can substitute small n is equal to 2. So mole 1 minus 2, liter 2 minus 1, and per time. So unit will be per mole, liter, per time. So option in which this particular unit is present, that one is your example of second order reaction. And this per mole, liter, per time, this unit is present in option C. So for question number 20, answer is option C. Question number 21. The cell constant of conductivity cell having electrode of area 0.85 centimeter square and 1.1 into 10 raised to minus 3 meter apart is. You have to find out cell constant. The formula to determine cell constant is L upon A. So if you substitute that values of L and A, area, L distance of separation, A area, okay, that is 1.1 into 10 raised to minus 3 upon 0.85, you will get answer 1.29. So answer is 1.29 per centimeter. Next question. On passing 1 Faraday of electricity through the electrolytic cells containing Ag plus, Ni2 plus, Cr3 plus ions, the deposited Ag, Ni and chromium is. simply amount deposited by 1 Faraday of charge is nothing but amount deposited by 1 electron. So here equivalent weight of your Ag will be atomic weight upon 1 because it carries +1 charge. So equivalent weight of Ag will be 108. Equivalent weight of Ni, it will be atomic weight upon 2 because nickel carries +2 charge. That is 59 upon 2. It will be 29.5. Equivalent weight of chromium, it will be 52 upon 3 because chromium carries +3 charge. It is 17.3. So when we consider amount deposited by 1 Faraday charge, it is 108 for Ag, 29.5 for nickel, and 17.3 for chromium. So answer is your option A, 108, 29.5 and 17.3. Then question number 23. The molar conductivities of KCl, NaCl and KNO3 are 152, 128 and 111 Siemens per centimeter per mole respectively. What is the molar conductivity of NaNO3? See, simply question is based upon your Corlosh law. So by using Corlosh law, you can find out the relation or the equation to find out that molar conductivities for NaNO3. Here I can show that application of Corlosh law to find out that molar conductivity of NaNO3. So molar conductivity of NaNO3 is equal to molar conductivity of NaCl plus molar conductivity of KNO3 minus molar conductivity of KCl. Why? Because we want Na plus and NO3 minus ion. So in these three salts, Na plus Cl minus, K plus NO3 minus, K plus Cl minus. So if we add Na plus and KNO3 and subtract KCl, remaining ions which are nothing but Na plus and NO3 minus. So values of that molar conductivities are given. For NaCl it is 128, for KNO3 it is 111 and for KCl it is 152. So you will get final answer that 87 Siemens per 87 Siemens centimeter square per mole. So your answer is option B, 87 Siemens centimeter square per mole. While charging the lead storage battery, when we charge that particular lead storage battery, reactions which are take place at cathode and anode, those reactions are exact opposite which take place while discharging of lead storage battery. So when while charging that lead storage battery, PbSO4 get oxidized at anode to PbO2 and PbSO4 get reduced to Pb at cathode. So in this question, two correct answers are there, that is option C and option D. Both answers are correct. Option C and option D. Question number 25. A silver cup is plated with silver by passing 965 coulomb of electricity. The amount of Ag deposited is. Amount of Ag deposited is. So to find out that amount of Ag deposited, we can simply use the formula. Amount of Ag deposited is equal to, here, equivalent weight into Q charge. upon 96500. So equivalent weight will be 107.87 as valency is 1 into 965 upon 96500. So you will get answer 1.0787 gram. Answer is option D, 1.07.87 or 89 gram. Then question number 26. The specific conductance of 0.1 molar KCl solution at 23 degrees Celsius is 0.012 per ohm centimeter square. The resistance of cell containing the solution at the same temperature was found to be 55 ohm. The cell constant will be. See, we have to calculate that cell constant, and specific conductance is given. Okay, and resistance is also given. So we can use a formula of specific resistance, specific conductance. K is equal to 1 upon R into cell constant. So cell constant is equal to K into R. The specific conductance is given 0.012 and value of resistance is 55 ohm. So simply by multiplying that 0.012 and 55, you will get answer 0.66 per centimeter. So your answer is 0.66 per centimeter. Question number 27. A solution containing 1 mole per liter each of CuNO3 twice, AgNO3, Hg2NO3 twice, and MgNO3 twice is being electrolyzed by using inert electrode. The values of standard electrode potential in volt are. Those values are given for silver, it is 0.80 volt. For mercury, it is 0.79 volt. For copper, it is 0.34 volt. And for magnesium, it is minus 2.37 volt. With increasing voltage, the sequence of deposition of metal on the cathode will be. See, higher the reduction potential, higher the tendency of deposition. But from the given values, value for magnesium is negative. So it do not have tendency to deposit. So order will be Ag, then Hg, and then copper. Because value of Ag, silver, that is 0.80, that is a maximum value. So its tendency to get deposit is more than mercury, 0.79 volt, and then your copper, 0.34 volt. So answer is option C. Question number 28. What will be the EMF for the given cell? See, hydrogen cell is given and you have to find out that EMF equation for that particular hydrogen cell. So either you can keep in mind for from theory, or simply you can use equation E of a cell is equal to E0 of a cell minus RT upon NF into ln P2 by P1. Okay. So as that and as that given cell is a hydrogen cell, E0 is a E0 of a cell is a 0. So you can substitute that E0 of a cell as a 0. So equation will become minus RT upon NF into ln P2 by P1. So if you look at that cell, to get reduce that hydrogen gas, you will require 2 moles of electron. So your N will become 2 and your final equation will become E of a cell is equal to RT upon 2F into ln P1 by P2. Why P1 by P2? because minus, to remove that minus sign, that ratio of P2 by P1 get reversed, that is P1 by P2. So answer will be option B, RT upon 2F log of P1 by P2. Question number 29. For the reaction N2 plus 3H2 gives twice NH3 if change in concentration of ammonia is 2 into 10 raised to minus 4 mole per liter per second, the value of change in concentration of hydrogen would be. See, from this given equation, from this given chemical equation, we have to write the instantaneous rate law for this particular reaction, which can relate the values of change in concentration of ammonia and change in concentration of hydrogen. So when you write that instantaneous rate law for that particular reaction, for that particular equation, it will be minus concentration of N2 upon delta T is equal to minus 1 by 3 concentration of H2 upon delta T, which is equal to plus 1/2 concentration of NH3 upon delta T. See, for hydrogen, we have to find out that concentration, and for ammonia, that value is given. So simply we can relate that terms of hydrogen and ammonia. So equation, on rearranging, the equation will become minus delta concentration of H2 upon delta T is equal to 3 by 2 D concentration of NH3 upon delta T. So value of D concentration of NHT upon delta T is given, that is 2 into 10 raised to minus 4. So by solving that particular term, you will get answer 3 into 10 raised to minus 4. So answer is 3 into 10 raised to minus 4 mole per liter per second. Question number 30. When zinc pieces is kept in CuSO4 solution, copper get precipitated due to standard potential of zinc is, whether it is greater than 0, less than, whether it is greater than copper, less than copper, greater than sulfate, or less than sulfate. See, here copper get precipitated due to standard reduction potential of zinc is less than that of copper. Standard reduction potential of zinc is less than that of copper. So answer is option B, less than copper. Question number 31. The half-life of first order reaction is 10 minutes. If initial amount is 0.08 mole per liter and concentration at some instant is 0.01 mole per liter, then T is equal to. See, half-life is given. So from that half-life, we can find out value of K by using the formula for half-life of first order reaction, that is T half is equal to 0.693 upon K. Value of K is given. Value of T half is given and we can find out K. Therefore, K is equal to 0.693 upon 10. Therefore, K is equal to 0.0693. So now by using this K, we can calculate that time required for that particular conversion of 0.08 mole to 0.01 mole. So here I can use K is equal to 2.303 upon T log to the base 10 concentration of A at a 0 upon concentration of A at a time T. The value of K, which is find out, is 0.0693 is equal to 2.303. T, we have to find out time required, log to the base 10. Initial concentration is 0.08. Final concentration is 0.01. So this ratio will become 8. So I can write T is equal to 2.303 upon 0.0693 log to the base 10, 8. Okay. So if you solve this particular equation, you will get T is equal to 30 minute. T is equal to 30 minute. So answer is 30 minute. Then the data for the reaction A plus B gives C is tabular data is given, and you have to find out rate law for that particular reaction. As we know, when the question is like this, find out the rate law, we have to find out the values of X and Y. So for that, first of all, we have to find out the pair of rate equation from that given tabular data. So that in the first case, we can cancel either terms of X or terms of Y. So I can select second and third equation. And from that second and third equation, I can get value of Y is 3. And to find out value of X, I can select second and fourth equation. So by selecting second and fourth equation, I can get value of X, which is nothing but 0. So my rate law will become rate is equal to K into concentration of A raised to X. Now value of X is a 0 and concentration of B raised to Y. Value of Y is a 3. So my rate law is K into concentration of B raised to 3. So answer is option A. Rate is equal to K into concentration of B raised to 3. 33. The thermal decomposition of compound is of first order. If a sample of compound decomposes 50% in 120 minutes, in what time it will undergo 90% decomposition? See, again from given information, we have to find out first of all that value of K for that first order reaction. So as T half is given, because the sentence is if the sample of compound decomposes in 50% in 120 minutes. So indirectly T half is given. So I can consider that 120 minute as a T half. So I can write here K is equal to 0.693 upon T half. Now T half is 120 minutes. So I can write 0.693 upon 120, which is nothing but 0.00577. It is my K. So by using that K, I can find out that time required for that particular conversion. So 2.303 upon T log to the base 10, as 90% decomposition is there, I can consider initial concentration 100 and final concentration 100 minus 90, that is a 10. So value of K 0.00577 equal to 2.303 upon T log to the base 10 of 10. Okay. So the value of log to the base 10 is 1. So T is equal to 2.303 upon 0.00577. So T is equal to 399, which is approximately equal to 400. So your answer is nearly 400 minutes. Your answer is nearly 400 minutes. Which among the following is a false statement? First statement is half-life of third order reaction is inversely proportional to the square of initial concentration of reactant. Yes, it is a correct statement that half-life of third order reaction is inversely proportional to square of initial concentration. Second, molecularity of reaction may be zero or fractional. No. Order of reaction may be zero or fractional. Order of reaction is purely experimentally determined quantity, but molecularity is always whole number, and you can find out molecularity from balanced chemical equation. So that statement B is a false. Let us check remaining two statements also. See, for a first order reaction, T half is equal to 0.693 upon K. Yes, for first order reaction, that relationship between rate constant and half-life is 0.693 upon K. Last one is rate of zero order reaction is independent of initial concentration of reactant. Yes, that statement is also true, because the meaning of zero order reaction is nothing but that rate is independent of concentration of that particular species, means power is zero. So here false statement is second statement, that is B, molecularity of reaction may be zero or fractional. Question number 35. Which equation is correct for first order reaction? Which equation is correct for first order reaction? So the relationship between half-life period and initial concentration for nth order reaction is given by this particular equation, that is T half is directly proportional to 1 upon C raised to n minus 1. So for first order reaction, we can substitute small n by 1. So equation will become T half is directly proportional to 1 upon C raised to 0. Or I can write T half is directly proportional to C. So your correct answer is option C, T half is directly proportional to C raised to 0. Question number 36. A device that converts energy of combustion of fuel like hydrogen and methane directly into electrical energy is known as, that device is nothing but your fuel cell, which convert energy of combustion of hydrogen and methane into electrical energy. That is simply your fuel cell. Question number 37. When 0.1 mole MnO4 2- is oxidized, the quantity of electricity required to completely oxidize MnO4 2- to MnO4- is. See, you have to oxidize MnO4 2- into MnO4-. So if you find out oxidation state in MnO4 2-, oxidation state of Mn is +6, and in MnO4- that of oxidation state of Mn is +7, means there is a transfer of 1 electron. So 1 mole of MnO4- require 1 Faraday of electricity. Why 1 Faraday? Because 1 mole of electron is required for the given conversion. 1 Faraday is nothing but 96500 coulomb. So question is for 0.1 mole. So for 1 Faraday 96500, so for 0.1 Faraday, it will be 0.1 into 96500. Answer will be 9650 coulomb. So answer is your option A, 9650 coulomb. Question number 38. The molar conductivity of 0.007 molar acetic acid is 20 Siemens centimeter square per mole. What is the dissociation constant of acetic acid? Choose the correct option. See, molar conductivity of H plus ion is given and that of CH3COO minus acetate ions are also given. You have to find out dissociation constant. Okay. Now, dissociation constant can be found out by using your Ostwald's dilution law. So formula to find out dissociation constant is Ka is equal to C into alpha square. Ka is equal to C into alpha square. Again, alpha is not given. So to find out that dissociation constant, first of all, we have to find out alpha. So we can find out that alpha by using equation alpha is equal to molar conductivity upon standard molar conductivity. Okay, now that molar conductivity is given, that is a 20. But standard molar conductivity, we have to find out. How? By using your Coriolis law. Standard molar conductivity of acetic acid is equal to standard molar conductivity of your acetate ion CH3COO minus plus standard molar conductivity of your H plus ion. So for acetate ion value is 50 and for H plus ion value is 350. So here answer is 400 Siemens centimeter square per mole. So now by using this value, I can find out value of alpha, which is equal to 20 upon 400, which is equal to 1 upon 20. So now by using this alpha, I can find out value of Ka. So Ka is equal to, see, concentration is given, that is 0.007. So I can write 7 into 10 raised to minus 3 into alpha, that is 1 upon 20 bracket square. So by solving this particular, we will get 7 into 10 raised to minus 3 into 1 upon 4 into 10 raised to minus 2. It will be 7 by 4 into 10 raised to minus 5. So it is 1.75 into 10 raised to minus 5. So answer will be option A, 1.75 into 10 raised to minus 5 mole per liter. Then find out the EMF of the cell in which the following reaction take place at 298 Kelvin. You have to find out EMF of cell. So formula to find out EMF of cell is E of a cell is equal to E0 of a cell minus 2.303 RT upon NF into log to the base 10 concentration of product upon concentration of reactant. See, value for E0 of a cell is given. So simply you can substitute that value of E0 of a cell. For N, as a 2 electrons are transferred for the complete reduction, we can get value of N as a 2. Then in given information 2.303 into RT upon F, that value is directly given, that is 0.059. So simply you can substitute the concentration of Ni2 plus and concentration of Ag plus. And by solving that particular equation, you will get answer 0.9615 volt. Simple substitution problem is there. formula is E of a cell is equal to E0 of a cell minus 2.303 RT NF log to the base 10 concentration of product upon concentration of reactant. Answer is 0.9615 volt. Then question number 40. Which reaction is not feasible? Which reaction is not feasible? See, from given reaction, if you observe second reaction, that second reaction, it is not feasible because more reactive element displaces the lower reactive element from their aqueous solution. Halogen have strong tendency as a oxidizing nature, or halogen have a strong oxidizing nature, and Br minus is oxidized only by chlorine or fluorine and not by iodine. So that second reaction is not feasible reaction. 41. Without losing its concentration, ZnCl2 solution cannot be kept in contact with. So without losing its concentration, ZnCl2 solution cannot be kept in contact with aluminium because aluminium has a lower electrode potential than zinc. Therefore, it reduces Zn2 plus to zinc, while all other given options have higher electrode potential than zinc. So without changing concentration, ZnCl2 cannot be kept in contact with aluminium because of its lower electrode potential. Then 42. The standard EMF of a galvanic cell involving cell reaction with N is equal to 2 is found to be 0.295 volt at 25 degrees Celsius. The equilibrium constant of reaction would be, you have to find out equilibrium constant. Equilibrium constant means you have to find out Kc. So to find out that Kc, you can use the equation E0 of a cell is equal to 0.0591 upon N into log to the base 10 of Kc. So here I can write that equation, that E0 of a cell is equal to 0.0591 upon N log of Kc. So to find out Kc, I can rearrange equation. Log of Kc is equal to E0 of a cell into N upon 0.0591, which is equal to E0 of a cell is 0.295. N is given, that is 2 upon 0.0591. So log of Kc is equal to 10. So to find out that Kc, we have to take anti-log of both sides, and value of Kc will become 10 raised to 10. Value of Kc will become 10 raised to 10. And your correct answer is option D, 1 into 10 raised to 10. The rate of reaction double when its temperature changes from 300 Kelvin to 310 Kelvin. Activation energy of such a reaction will be. Activation energy for such a reaction will be. See, rate of reaction double when its temperature changes from 300 Kelvin to 310 Kelvin. So comparison between two rate constants are given and two different temperatures are given, and you have to find out energy of activation. So ultimately your formula is log of K2 by K1 is equal to EA upon 2.303 R into bracket T2 minus T1 upon T1 into T2. So as rate of reaction doubles, so K2 I can consider 2R1. So log of 2R1 upon R1, log of 2. EA we have to find out 2.303 into value of R 8.314, T2 310, T1 300. So by solving that particular equation, you will get answer in joule, that is 53606 joule. But in option, kilojoule per mole unit is given. So convert that joule into kilojoule. So answer will be 53.606 kilojoule. Next, for a first order reaction, A gives product. The concentration of A changes from 0.1 molar to 0.025 molar in 40 minutes. The rate of reaction when the concentration of A is 0.01 molar is, see, two-step problem. From given information, first of all, we have to find out K from that first order equation. K is equal to 2.303 T into log to the base 10 initial concentration upon concentration at a time T. So by using this information, you will get value of K as a 0.034. But your final question is rate of reaction when concentration of A is 0.01 mole. So for that, rate, I can write rate law. Rate is equal to K into concentration of A raised to X. But as reaction is first order, I can consider X as a 1. So my rate law become rate is equal to K into concentration of A raised to 1. Already from the previous data, I have find out that value of K, which is 0.034, and concentration of A is given, that is 0.01. So by simply substituting that value of K and concentration of A in that rate law, I will get the answer 3.4 into 10 raised to minus 4. So answer is option C, 3.4 into 10 raised to minus 4. Next, the rate of chemical reaction doubles for every 10 degrees Celsius rise of temperature. If the temperature is raised by 50 degrees Celsius, the rate of reaction increases by about. See, for every 10 degrees Celsius, rate of reaction get double. So I can consider 2. As rate of reaction double, I can consider 2. But here temperature is increased by 50 degrees Celsius. So 5 times that temperature is increased. So I can consider 2 raised to n. Value of that n is a 5 because temperature is increased 5 times 50 degree Celsius. So answer of 2 raised to 5 is 32. So answer is 32 times. Answer is 32 times. Then higher order reactions are rare due to, see, higher order reactions means greater than third. It is because of low probability of simultaneous collision of all the reacting species. For the conversion of reactant into product, that reactant molecule must collide with each other. It is according to our collision theory. But if order of reaction is higher, so it is necessary at a time that collision of all reacting species must take place to form product, which is quite difficult, or probability of simultaneous collision of all reacting species is very low. So here answer is option C. 47. The half-life period of first order chemical reaction is 6.93 minutes. The time required for the completion of 99% of chemical reaction will be. Again, two-step problem. Half-life period of first order chemical reaction is a 6.93 minutes. So from that half-life, we have to find out that value of rate constant K. Okay, then by using that K, we can find out that value of time required. So from that given information, value of K is 0.1, and by using that value of K, we can find out time required for 99% completion, which is 46.6 minute. 46.6 minute. 48. Consider the reaction Cl2 plus H2S gives sulfur plus 2H plus twice Cl minus. The rate of this reaction is equal to K into concentration of Cl2 into concentration of H2S. Which of these mechanism is or are consistent with this rate equation? See, in this type of question, first of all, we have to find out the rate law from that given two different mechanism. We can find out rate law from the slow step. In the first mechanism, your first step is a slow step. So from that first slow step, I can write rate law as a rate is equal to K into concentration of Cl2 raised to 1, concentration of H2S raised to 1, which is identical with that of the given rate equation. Let us check for the second mechanism. For the second mechanism, slow step. For second mechanism, slow step is a second step, and from that second slow step, I can write rate law as a rate is equal to K into concentration of Cl2 raised to 1 and concentration of H S minus raised to 1. So if I want to write it in the form of H2S, I have to write concentration of H2S raised to half, because one hydrogen is less. So that rate law is not identical with that of given rate law equation. So only first mechanism is consistent with the given rate law. So answer is option A, only one, only first mechanism. 49. For a given reaction, T half is inversely proportional to Ka. The order of reaction is. For a given reaction, T half is inversely proportional to Ka. The order of reaction is. See, here the T half, basically T half is inversely proportional to Ka for your second order reaction. So your order of reaction will be second. Or simply you can calculate by using T half like this. Just a minute. Simply you can calculate like this. T half is inversely proportional to 1 upon A raised to n minus 1. Okay. So to get that T half inversely proportional to Ka, power of Ka is a 1. So to get that power 1, value of n should be 2. So therefore it is your second order reaction. So answer is a second order reaction. Last question. Hydrolysis of DDT is a first order reaction. Its half-life is 10 years. Time to hydrolyze 10 gram DDT to half is. See, again, hydrolysis of DDT is a first order. Its half-life is 10 years. From that half-life information, we have to find out value of K. That is, K is equal to 0.693 upon T half. So T half is 10 years. So your value of K become 0.0693. So by using that value of K, we can find out time required to hydrolyze 10 gram of DDT. So initial concentration of DDT is a 10 gram. So my initial concentration will be 10 and half, we have to hydrolyze half quantity. So final amount will be 5. So 2.303 upon 0.0693 log to the base 10, 10 upon 5. So you will get final answer 10 year. So answer will be 10 year. Answer will be 10 year. Okay. That's it. Thank you so much.